Alright class, welcome back. In today's video we're moving on to evaluation of limits analytically. So let's go ahead and get started. So first and foremost, I am going to share with you a few properties of limits that you should know. So I'm going to go ahead and project them here in the camera. So if you're watching the video, I would just say pause the video, copy them down, and when you're ready just hit play and we'll talk about them. But here's some of the properties. So basically you have, if the limit as x approaches c of a constant, then it should just be the constant itself. The limit as x approaches c of x would equal to c, and the only way that that could happen, guys, is literally just think about it. If you plug in c into x, you would get c, right? Which is the same idea here on this one. The limit as x approaches c of x to the n. Well, think about it. If you plug in c for x, you're going to get c to the n. Now, it's very important for me to mention, I think this should be obvious, that the letters b, c, and n are real numbers in this case. Okay. Some more properties here. Some information to know beforehand is that L and K are real constants, as well as b, c, and n like before. And we're going to let the limit as x approaches c of function of x be L, and the limit as x approaches c of function of g of x equal to k. So very simple. If we have the limit as x approaches c of a constant multiplied by f of x, then it's going to be b times L, because the limit as x approaches c of f of x is equal to L. Now we have the addition or subtraction of two functions. So the limit as x approaches c of f of x plus or minus g of x, you can take the limits separately and just add them, so L plus or minus k. With multiplication, if we were able to do that with addition or subtraction, we should be able to do that with multiplication as well as with division. Just keep in mind that with division, the denominator cannot equal to 0. If you have a function that is to a power, so the limit as x approaches c of f of x, remember that was equal to L, so that's still going to be L to the n power, whatever that is. And the limit as x approaches c of the nth root of x would be equal to the nth root of c. One of the things I want you to notice about this is that we keep substituting in c for x, and that's what's happening on this one, that's what happened on a few others, so like the top one and this one. Okay, so that is going to be one of our techniques of evaluation, which is direct substitution. But we have one more property to talk about, which is in case you have a composite function. So let's say some information beforehand. We're going to let the limit as x approaches c of g of x equal to L, and the limit as x approaches L, so we'll talk about this here in just a second, of f of x equals to f of L. That makes sense. We're just going to substitute in for x this value, which in this case is L. Now, why am I writing this? Let's take a look at this statement here, and it's going to make a little bit more sense. This right here says the limit as x approaches c of f of g of x, which if you look at this is a composite function. Now really what's going to happen, guys, in order for you to do a composite function is you first have to plug in c into g of x, and you got to take the limit of that. So what happens is you take the limit as x approaches c of g of x, which is going to give you an answer. Cool. Whatever you get in the answer for that, all you got to do is plug it into f. So in that case you're going to get f of L. And that's the reason for this statement here. So the limit as x approaches L is f of x is equal to f of L. Okay. Now, those are a lot of properties to memorize. However, with enough practice, or with practice, not really with enough practice, you should be able to attack those types of problems. So let's go ahead and do some examples to make sure that you understand these techniques. So example number 1, let's say that we have the limit as x approaches 1 of x squared plus x plus 2 divided by x plus 1. Okay, so the first technique you're going to try is called just substitution. Substitution is really what it sounds like, and I hope I spelled that correctly. All you're going to do is substitute this value in for x. So what's going to happen in this case is we're going to get the limit as x approaches 1, and you're going to continue to write the word limit until you actually find the limit. So the limit as x approaches 1, we're going to substitute in 1 for x. Now typically I wouldn't show all this work, and you don't have to either if you can do that. So you can go straight to the answer, but I'm just going to go ahead and show the work. So 1 squared is 1, plus 1 is 2, plus 2 is 4, and then 1 plus 1 is 2, which means 4 divided by 2 is 2. Notice how by substitution I've already used some of those properties that we talked about in the past, so that's why I share them with you to know that they exist, but some of this is just common sense. With substitution you're just going to be able to plug in and get an answer out of that. Now, if you watch the previous video, sometimes you're going to get the indeterminate form, and if you get that, then you got to try something else. Cool? Which is actually my example number 2. So let's say that you take a limit, and I believe, I'm not 100% sure, but I might have done this problem last class. So x to the third minus 1 over x minus 1. Okay, so let's say we want to attempt that problem with direct substitution. It should be relatively obvious, guys. If we plug in 1 to the third is 1 minus 1 is 0, which is no problem. We have a 0 in the numerator, okay? But if we put 1 in the denominator, 1 minus 1 is 0, we're going to get 0 over 0, which we talked about last time. This is called the indeterminate form, I'm sorry. And as of right now, I'm just going to say that it is called the indeterminate form. Very soon I'll explain to you what that means and how you actually solve this problem. It's a lot easier. But for now, we're just going to say, hey, it's a problem algebraically. We're not going to be able to solve it, so we have to figure something else out. So this is where your algebra techniques will come into help. So the very first technique that I recommend you use is called the dividing technique. So we're going to do the dividing technique. So the dividing out technique, well, really what that means, guys, is factor out the expression. If anything cancels, that's dividing out, right? Or you could try long division. But in my opinion, in my honest opinion, you should just try to factor this out and divide that way. So x to the third minus 1 is a difference of cubes, which hopefully we know that how to factor those. So I'm going to go ahead and factor this out. The x minus 1, it stays on its own. So we're going to have an x minus 1 here, and then we're going to have an x squared. And then we're going to have a plus x and a plus 1. Okay, if you need help with factoring out a difference of cubes, you can go ahead and look that up on YouTube if you need to. But anyways, now that I have this expression, it should be relatively obvious that with the division, this term and this term will cancel out. And then I will go back to the very first technique, which is just substitution. If it works, fantastic, we'll move on. So I'm going to go ahead and plug in 1 squared plus 1 would equal to 3. So therefore the limit is equal to 3. Okay, hopefully you're finding this to be relatively simple. I'm gonna do a few more examples of other techniques, and the time for you to practice is really gonna be during your homework, guys. I don't want to make this video super long. Okay, so let's try out another problem, see how we can come up with a solution for that. Let's see here. Let's try out this one. So example number 3. What is the limit as x approaches negative, I'm sorry, 0, not negative, sorry, as x approaches 0 of the square root of x plus 1 minus 1 divided by x. Okay, so once again, the very first thing you should try, and I recommend every single time, is to just plug in to see what happens. So if I plug in 0, okay, so we get square root of 1, which is 1 minus 1 is 0, over 0. So once again, I get that indeterminate form. So I'm going to attempt something else algebraically. So in this case, I look at this, and there's really nothing out to divide, so division might not be the best way to go. So maybe I need to try another technique. Now, when I see this problem, I think of something called rationalizing. Now, why do I know to rationalize? Anytime you see a square root plus or minus a constant in a rational function, you may want to think of rationalizing. So think back to Algebra 2, what it means to rationalize. Okay, so to rationalize, remember, is to multiply by the conjugate, or really to rationalize, to multiply by itself by a, so if it's a root, by its own root, so we can get rid of the root. But in this case, because we have this constant, we're going to multiply by what we call the conjugate. Now remember, the conjugate is when you have two terms and you switch the sign in between the two. Okay, so in this case, what I'm going to do, go ahead and switch color. So I'm going to say the limit as x approaches 0 of the square root of x plus 1 minus 1 divided by x, I'm going to multiply by the conjugate of x plus 1 minus 1, which is in this case plus 1. Now, remember, in algebra, if you're going to make a change to the numerator of a fraction, so you have to do to the denominator. So I'm going to go ahead and multiply the denominators as well. Okay, I'm going to multiply that out. So I'm going to get this here. So the limit as x approaches 0 of square root of x plus 1 times square root of x plus 1 is simply going to be x plus 1. Now remember, conjugates cancel the middle terms, so I'm not even going to bother with the middle terms. Negative 1 times 1 is going to be negative 1. And here's the key. Do not actually multiply this in. The whole idea is, think this through. We were getting 0 in the denominator here, so we want that x to go away. So we want to have it by itself so that it can divide out. So I'm going to have that x by itself, and then I'm going to have the square root of x plus 1 plus 1. Cool? Now, if we clean this up, we have the limit as x approaches 0. Once again, notice how I keep writing the word limit as I go until I actually find the limit. So x plus 1 minus 1, the plus 1 minus 1 cancels, leaving you with just x. And fantastic, because that x is going to get rid of that x that we had a problem with, so that's going to go away. So technically we are left with 1 over the square root of x plus 1 plus 1. So now that you've actually performed the whole rationalization and simplified the statement, once again you go back right to the beginning, which is the very first thing you should always try with a limit, which is substitution. If I plug in 0, 0 plus 1 is 1, square root of 1 is 1, plus 1 is 2. So the answer for this limit would be 1/2. So that right there is called rationalizing. Okay, for our next example, let's say that you are given the following. Let's say that f of x is equal to 5 minus x. And let's say that g of x is equal to x to the third. And you are asked to find the limit as x approaches 1 of g of f of x. Okay, so previously, as you can see, this is going to be a composite function. So previously I gave you some properties for that for you to figure this out. You can break this up into 2 limits. However, I'm going to be completely honest with you. The more algebra you know, the easier this is. And I'm going to solve it both ways. But think this through. How about instead you just figure out what this is first and then just plug in the 1. That's really what goes through my brain every time I do these types of problem. To me, that's a lot easier. So we're going to go ahead and try that, and then we go back and try the properties. So first I'm going to pause on the calculus, and I'm going to ask myself, well, what is g of f of x? Well, g of f of x is when you take the g function, so in this case it's x to the third, but you plug in the 5 minus x. So g of f of x is 5 minus x to the third power, and I'm not going to actually multiply all that out. That's really what it is. There's no reason for me to do it. So what's going to happen is very simple. Now what I'm going to do is I'm going to go back to this statement and take the limit. So I'm going to say, well, the limit as x approaches 1, this statement, I'm going to replace it with that. So 5 minus x to the third. And then it becomes very simple. So I'm literally going to use substitution. Put in the 1. So 5 minus 1, it is going to be equal to 4. And 4 to the third power is going to be equal to 64. So I'm going to substitute in the 1, and I get the 64. So to me, that's the easiest way to go about it. Now let's say you want to use the properties, right? So let's go back. The property said pretty much that you first have to plug in the 1 into this function right here. So in this case, we're going to plug in, we're going to find the limit. So I'm going to use a different color. The limit as x approaches 1 of f of x. Well, in this case, f of x is 5 minus x, which in this case you get 4, right? Now, what the property says is, once you find the limit, you take this right here. So now you're going to say the limit as x approaches 4, and all you got to do is plug it into the, in this case, the g function, which in this case is going to be x to the third. So it's x to the third. So what that does is 4 to the third is 64. So, I mean, you get the same answers. To me, it requires you to do more work if you do this, when you can simply just use your algebra skills, figure out what the composite function actually is, and then just use substitution if it works. If substitution doesn't work, then you can try dividing out technique or rationalizing technique. Okay? All right, last example for this video. Let's say that we have the limits as x approaches 2 of 1 divided by x plus 2 minus 1/4, all of that divided by x minus 2. Okay, so once again, the first thing you should try is just substitution, but it's going to be very obvious right here, guys. We get 1/4 minus 1/4 is 0 over 0, so we're going to have that indeterminate form once again, which means you should try another technique. Thinking of the techniques that I have thus far, I mean, this isn't really a composite function. This isn't something I can divide out. This is definitely not a conjugate scenario here where I can, a rationalizing scenario where I can use a conjugate. So at this point, you have some choices, right? Or you're kind of stuck, really, and you have to make a choice. What I want to make sure, and I forgot to mention at the beginning of this video, is don't forget that, I mean, these are techniques to do it algebraically, and if you get stuck, you can always rely back on what you learned in the last lesson, which is, hey, visually, which means that you would have to graph this out. Now, this doesn't look like a fun thing to graph, so maybe we can try to see if we can actually do some algebra here. So what I mean by that is, well, I don't like the fact that I have fractions on top of fractions, etc., etc. So maybe all I have to do is really just kind of clean things up and see if anything improves. So that's what I'm going to go ahead and tackle. So right here I have two fractions. I'm going to get a common denominator, which means I'm going to multiply this 1 by 4. And I'm going to multiply this by x plus 2. So that common denominator now would be 4 times x plus 2. And then I still have my x minus 2 down here. So let's go ahead and continue to clean that up. So the limit as x approaches 2. So what do I have here? 4. So if I distribute that, becomes a negative x minus 2. So that's really 4 minus 2, which is 2. And then minus x all over 4 x plus 2 all over x minus 2. Right? So now what could I do here? Well, let's kind of look at this. I see it, but I just want to make sure you guys see it. So it bothers me to have a fraction over a fraction. That still hasn't fixed. Remember, it's like technically I have this over 1. It's another fraction. So what I can do is, I'm kind of running out of space. I'm going to go over here. So I'm going to say the limit as x approaches 2. I'm going to leave that top alone. So that's technically saying negative x plus 2 divided by 4 times x plus 2. And that's like multiplying. Remember, when you're dividing fractions, you multiply by the reciprocal, which in this case would be 1 over x minus 2. Right? So if I do so, I get the following. I'm like, okay, that times that is just itself. And then that times that will, I don't really want to multiply, right? Here's the thing, guys. We still have this problem. If I plug in the 2 here, right, which is what eventually we want to do, that's going to go to 0. So anything times 0 is going to give us 0. So we want to find a way to get rid of this, okay? X minus 2. And the only way that x minus 2 is going to happen, it's going to go away, it's if it happens to be up here. Well, it's technically there, you just have to rewrite it differently. What I'm going to do is I'm going to factor out a negative 1. So if I factor out a negative 1, I would be left with x minus 2. So think about it. Negative 1 times x gives you the negative x. Negative 1 times negative 2 gives you the 2. So now I'm just going to go ahead and write this since I've already started writing that statement. You'll notice that the x minus 2 would cancel out. And I have the limit as x approaches 2 of negative 1 over 4x plus 2. So this really isn't have a name. It's not really a technique. Sometimes you just have to play around with algebra, something that looks very messy. Maybe you just can clean it up. It started looking like this, and now it looks like this. So now I'm just going to see if substitution would work, which in this case should. So if you plug in 2, 2 plus 2 is 4. 4 times 4 is 16. So the final answer for this would be negative 1 over 16. Okay? So there you have it. Those were several examples. I didn't really give you time to practice because I want you to practice this on the homework. So keep in mind you have a lot of strategies to try out. In other words, it's just your algebra skills here are going to be very, very essential in order for you to find these limits. Try as many things as you possibly can think of, and remember, if any of the things that I showed you today fails, you can always graph and see if you can find the limit that way. Okay? Thank you for watching. We'll see you next time.